shift it, or it's possible you use a cosine curve and shift it. But today I'm going to teach you how, with the data that you're given, you're going to find some of these items. So in these problems, you are going to know or be easily able to spot the maximum and the minimum. Okay, so I want to think about the maximum of a sine curve and the minimum of a sine curve. Okay, let's take a look. So if I knew this maximum and I knew this minimum, couldn't I figure out two things? Couldn't I figure out the midline? Yes. So down here, when you're given information, K is our vertical shift or our midline, the way that you're going to figure that out is you are going to go halfway between the maximum plus the minimum. So we're going to take the maximum plus the minimum and we're going to divide it by 2 if there is a vertical shift today. Okay. The amplitude is simply the height of the wave, or think about this, the distance from the max to the min, and if you would take half of that, that is the amplitude. So our formula for finding the amplitude today is we're going to take the maximum minus the minimum, and we're going to divide it by 2. And that's a formula for helping us then spot our A. B has to do with our period, okay? So for B, we've been talking about, I'll do this on the board. We've been going the other direction mainly, where I'll say, what is the period? And you would tell me, oh, it's 360, and we divide it by B, right? Well, let's go the other way around. Let's say I didn't know what B was, but I knew what the period was. Let's solve this equation. I think I might have even showed you this yesterday. If I wanted to get B alone, couldn't I just divide by the period? So today we're going to determine the period. So in temperature data, the period is going to always be a year, okay, or 12 months. Sometimes I'll give you the time it takes for a cycle, but either way, if I want to figure out B, I am going to take 360 and I'm going to divide that by the period. Or, okay, we don't do a whole lot in radians this year. You will see this later on. What was 360 in terms of pi? It's right up there. 2 pi. So another way of thinking of this, if you were in radian mode, would be you could take 2 pi and divide by the period. Okay. How do we figure out H? This is the trickiest part, okay? It depends on what you're picking, because H is our phase shift. So if you are picking a sine curve, so I'm going to have 2 scenarios. With a sine curve, you want to pick when it's halfway between the min and max. Because when you're dealing with a sine curve, normally at 0 the sine curve starts in the middle. So if it doesn't start in the middle at 0, I'm going to have to shift it to where it starts. Okay, so either halfway in the middle between the min and the max if you're dealing with a sine curve. What does the cosine curve start with? It starts at its max. So if you want to, and this is where I'm saying some of us, there might be more than one answer. Because I could figure out this if I'm given it, but maybe you're going to also, so I'm going to write, or if you're dealing with the cos curve, you want to pick H to be when it's at a maximum, because that's where the cosine curve typically starts. Okay? All right. Also, highlighters are our friend here because we're going to have to kind of look at some information. Okay, so let's take a look at this scenario. I have a nice graph with it. Sometimes I'll just give you the words so you can kind of see that sine curve. This graph was plotted from data in which the maximum, ooh, I need that, tidal was 11.5 meters, okay? And the minimum was 1.5 meters. That is going to help us because that is going to help us figure out our A and our K, isn't it? Okay. The period is approximately 12.5 hours. Find a sinusoidal equation, use either sine or cosine for the graph measuring t units in hours. And I'm not going to even answer that equation yet. I'm going to just use my information at the top. Okay, so we got a max of 11.5 and a min of 1.5. Let's go ahead and figure out what is A and what is K, please. So for A, we're going to take the max minus the min. I'm just using that formula from above. And then we're going to divide that answer by 2. What is 11.5 minus 1.5? 10, right? 10 divided by 2 is 5. Okay. Next, I'm going to figure out my B value. Not my B value. I'll leave that for later. I'm going to do my other thing for max and min, which is my vertical shift. So we're going to do the max plus the min divided by 2 this time. 11.5 plus 1.5, divide that by 2. Let's see, 11.5 and 1.5 is 13, right? And 13 divided by 2 is 6.5. Okay. Were you given the period? Were we given the period? 12.5 hours, right? Okay. So when I'm looking at the period then, 12.5 hours for B, we're going to either 360 or 2 pi divided by the period. So it's either 360 divided by 12.5, which is what? Is that exact? Thank you. Or if it's in radians, it would be 2 pi divided by 12.5. So I'm going to also write that out just in case. We haven't dealt a whole lot with radians, but sometimes in these word problems they come up. All right, so if I did 12, all I did there was type in pi on my calculator. So I did 2 times pi, and then I divided it by b, and I got about 0.502. Did you say, was it you that Skylar said 28.8? Okay, is that right? I didn't do that one. All right, now, last thing. Let's see, who am I going to pick? Aiden, sine or cosine? Whatever you want. Okay, so if you're going to pick the cosine curve, what you're going to do is you're going to find, and it's a little bit hard to find it on this one, okay? Okay. A maximum, and that's going to be your phase shift. Okay, so if you were to pick a sine curve, remember, you would pick halfway in between. Like, for instance, doesn't that point right there look halfway between the min and the max? Okay, so either way, what does this look like to you? Let's make our best guess here. Okay, this is 0 to 24. Let's make a prediction. What do you think that is? It's not halfway, right? Kimberly, what does that look like to you? What if this is 0 and this is 24, what does that look like to you? Any guesses? Okay, 10, maybe 8, maybe, okay, it's definitely not halfway, but okay. So you want it to be 10. And then we're going to use a cosine curve. Let's put it all together. So my equation then would be y equals a. For a, I got 5. Cosine. I'll use the 28.8 because what I'm going to do in a second is I'm going to use my calculator, okay? And I'll just make sure if I'm using 28.8 that my calculator is in degree mode. If I wanted to use this, then my calculator would be in radian mode. That's the only difference. Okay, so 28.8 T. And we want to put a parentheses there because we're going to do our phase shift of 10 units to the right. And then our vertical shift was plus 6.5. All right, if you don't have one already, data today is going to be a little bit messy. And we're going to need a calculator. So if you don't have one, go grab one, please. If you have one of my graphing calculators, just because pre-calc has been using them a lot, would you make sure you go to the mode, and we need to make sure we're in degree mode. If you're using one of these calculators, they automatically default to degree mode, so you don't need to do that. So what are we going to do with our equation now? The question was, you use your equation to predict the tidal height at 6 hours. Okay, the tidal height at 6 hours. So I would literally put that in for T, and I'm going to type in that into my equation. So the way that looks, did I change my mode? I told you to, and then I didn't know if I did. Okay, the way that's going to look is 5 cos, and we're going to use parentheses just like we see, 28.8. Okay, if you want to do 6 minus 10 in your head, that's fine. You can literally type in 6 minus 10, but it is -4. And then we're going to close our parentheses and then plus 6.5. Okay. So according to my cosine curve, the height of the tidal wave at that point would be 6.07 feet. Okay, does that look like it makes sense using the graph? So Kimberly said that looked like about 10 to her, right? So wouldn't 6 hours be a little bit over here? And would a height of 6.07 look like it would match around then? Yeah, it does. I mean, that data point looks like it's pretty close to 6 to me. All right, cool. Let's look at what we have on